world over. It is very simple to write a moon song. First, of course, you must have the moon, preferably in the month of June. Someone to croon, and someone to write the tune. Add the word spoon, some flowers in bloom, and maybe even a honeymoon. Hit it, boys.
I see the moon shining down on lovers, spooning in the gloom. I see the moon on a sandy dune by a blue lagoon. All the hollyhocks in bloom fill the air with sweet perfume. Soon, pretty soon, love will bloom and you will croon. I see the moon that shines in June like a macaroon. I see the moon, we will sing it soon, rhyme it all with moon. Soon, spoon, June and moon, there'll always be a honeymoon. Honey, 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 moon, moon, moon. I see the moon that shines in June like a macaroon. I see the moon, we will sing a tune, rhyme it all with moon. Soon, spoon, June and moon, there'll always be a honeymoon. There'll always be a honeymoon.
Honey, honey, honeymoon with Daniel Boone.
There'll always be a honeymoon.
This, then, is the moon. Like a flower in heaven's high bower, with silent delight, sits and smiles on the night.
Astronomers tell us that the Earth we live on and the moon we see in the sky are but tiny specks in a tremendous universe that contains billions upon billions of stars and other worlds. Now, one of these tiny little specks, or stars, is our own sun. And circling around the sun is a system of 9 major planets. Except for Mercury and Venus, all of the planets have 1 or more moons. The giant Jupiter has 12, Saturn 9, Mars 2, and of course our Earth only 1. How the Earth and Moon came to be is a mystery. Astronomers speculate that about 4 billion years ago, our own universe was once a tremendous swirling cloud of cosmic gases and dust. Within this great nebula, smaller whirlpools of gaseous matter formed. These eddies of dust and hot gases gradually condensed to form our sun and planets. It is believed that at this early stage, the Earth and Moon evolved, with the Moon finally cooling to become a small, barren satellite 2,000 miles in diameter and circling the Earth once a month at a distance of 240,000 miles. Because the sun lights only half of the circling Moon, the Moon seems to gradually change shape during its monthly trip around the Earth. When the Moon moves between the Earth and the Sun, we see nothing but the dark shadow side. This is called the new Moon. Each night, as the Moon progresses along its circular path, we see slightly more of the lighted half. When it reaches a point on the opposite side of the Earth from the Sun, it appears to us as a full moon. Then, as the Moon continues its journey, we begin to see less and less of the illuminated half until finally it completes its monthly trip and becomes a new moon once again. Sometimes the circular path of the Moon carries it through the shadow of the Earth, and we observe the weird effect known as an eclipse of the Moon. On other rare occasions, during daylight hours, the invisible Moon passes squarely between the Earth and the Sun, and we are treated to the spectacle of a solar eclipse. Evidence of the Moon's influence on our daily lives is here demonstrated. The gravitational pull the Moon exerts on the oceans of our Earth causes daily high and low tides around the world. These various movements of our Moon through the sky have been observed and predicted for centuries. Today, with the help of modern telescopes and cameras, we are able to get a close-up view of the very unusual details on the Moon's surface. The prominent dark areas we see even without a telescope are large, flat plains surrounded by mountain ranges and craters. Some of the rugged mountain peaks rise straight up to 35,000 feet. And the craters range in size from small potholes to giant openings measuring 146 miles across. Scientists attribute the moon's rather rough surface to either volcanic action or to explosive hits by meteorites when the moon was in a molten stage. We've never seen the other side of the moon, but experts agree that it probably looks much like the side which always faces us. The moon is a dead world without atmosphere, a silent, unchanging desert where temperatures drop to 250 degrees below zero on the shadow side and boil at over 200 degrees in the direct light of the sun. But uninviting as it seems to be, man's restless search for knowledge of the universe will certainly make the moon one of his first objectives in the exploration of space. Here to reveal a plan for a trip around the moon is the chief of the guided missile development at the United States Army's Redstone Arsenal, Dr. Werner von Braun.
A voyage around the moon must be made in 2 phases. A rocket ship taking off from the Earth's surface will use almost all the fuel it can carry just to attain a speed great enough to balance the pull of gravity. Unpowered, it will then keep circling the Earth in an orbit outside of the atmosphere. This is the first phase. However, if we can refuel the ship in this orbit with fuel brought up by cargo rocket ships, it can set out on the second phase, the trip around the moon and back. To facilitate this refueling operation, we will establish an advanced base in the orbit, 1,000 miles above the Earth. This advanced base, or space station, will be headquarters for the final ascent to the moon. Our space satellite will have the shape of a wheel, measuring 200 feet across. Its outside rim will contain living and working quarters for a crew of 50 men. Just below the radio and radar antenna is the atomic reactor. Its heat will be used to drive a turbo generator, which supplies the station with electricity. Access to the station will be through an airlock in the hub. The 3 large spokes are elevator shafts, and the small pipes are used as condensers for the turbo generator and the air conditioning plant. The entire wheel will slowly rotate at 3 revolutions per minute. The resulting centrifugal force will produce an artificial gravity for the men in the rim. Notice that the floors are placed so that the men stand with their heads toward the hub. The wheel is divided into 9 sections. The first section is headquarters and communications. The next section will be for Earth weather observation and prediction. Military reconnaissance experts, aided by powerful optical and radar telescopes, will observe every point on the globe as the space station makes its complete trip around the Earth every 2 hours. Next is the emergency hospital section. And then the astronomy division, where men will keep an eye on the rocket ship as it makes its trip around the moon. The rest of the space station will house calculating machines, maintenance facilities, air conditioning equipment, living quarters, and even a botanical and zoological laboratory. This entire space station will have to be prefabricated and tested on the ground. After dismantling, it will be transported in pieces up to the orbit. For the difficult job of reassembling the structure, we have provided a new type of spacesuit. Using gyros and 2 small rocket motors, the operator can tilt and move in any direction. Located outside will be 7 remotely controlled mechanical arms, each a specialized tool. By rotating himself within the spacesuit, the operator can use any of the arms for the variety of tasks in assembling the space station. When the day arrives for construction to begin, the thousands of parts for the space station will be transported to the orbit by our multi-stage rockets. We merely replace the winged passenger section with a simple cargo-carrying nose. These cargo ships will be unmanned. A passenger rocket, 1,075 miles above the Earth, will guide each of the 12 approaching cargo rockets to their rendezvous in the orbit. This ship, which circles the Earth every 2 hours, will be the command post until after the space station is finished. On the ground, the first of the cargo rockets is ready for takeoff. When the guide ship reaches the correct position in the orbit, the cargo rocket is fired. While its motors are firing, the cargo rocket is controlled by an automatic pilot, like a guided missile. Up in space, the blast-off is observed with the aid of optical instruments. In the guide ship, the navigator locks his tracking radar on the rising cargo rocket. At about 24 miles altitude, the first stage breaks away and the second stage motors fire. 2 minutes later, the cargo head blasts away from the second stage and continues firing until its speed reaches 18,468 miles per hour. Automatically, the motor cuts off. Now, with the aid of remote controls, the navigator rotates the rising cargo rocket so that when it arrives later in the orbit, it will line up with the guide ship. Here, at 1,075 miles up, follows the most precise maneuver of the entire operation. The motor of the cargo rocket is fired again until its speed and course exactly match that of the guide ship. Radar remote control will enable this maneuver to be performed with a high degree of accuracy. 56 minutes have now elapsed since takeoff. The cargo ship is floating in space, 2,000 feet ahead of the guide ship. 2 crew members make their way to the cargo head to begin the unloading operation. First, the motor and tanks are detached. Then 2 bottle-type construction suits are removed from the hull. When fitted in the airlock, each of these construction suits will receive an operator. The sections of the cargo ship are moved back to make way for other supply rockets soon to arrive. Construction of the space wheel now begins. The sides of the cargo nose are mechanically separated. Built-in tanks of compressed air inflate this large plastic inner section of the hub. Thin metal plates are immediately clamped on the outside to protect it from meteors. The first workday in space draws to a close. Every 24 hours, another cargo rocket will arrive in the orbit. When the airlock is attached, the pressurized hub section can be used as temporary quarters for eating and sleeping. Each succeeding load is carefully scheduled so that the parts of the station can be assembled in correct order. Nylon ropes prevent the parts from slowly drifting away. Next, the atomic reactor is installed. The wheel begins to take shape now as the 3 main spokes and rim sections are joined together. Condenser pipes are fitted next so that the atomic reactor may be put in operation. Even though there's no apparent motion, everything in the orbit is hurtling around the Earth at 16,000 miles per hour. The shell of the station is completed. Now comes the delicate task of installing instruments and the multitude of equipment inside. Finally, 2 small rocket motors on the rim, blasting for a few seconds, will set the wheel in permanent motion to revolve 3 times a minute. As life on the station settles down to routine, the large reflecting telescopes will begin their work. These giant eyes relay pictures to television screens inside the station. One telescope photographs the surface of the Earth. Another keeps a constant watch on the Earth's weather, while the third is trained on our next objective, the Moon. The primary purpose of the first moon trip will be to test the methods and equipment to be used on later voyages into deep space. It will be essentially a scouting trip around the moon, and no landing will be attempted. To understand the plan of the trip, let us use this model. Here is the Earth with the moon circling around it. Since the first half of the trip will take 5 days, we must aim the ship well ahead of the moon so that they both arrive at about the same point in space